शुरू कर दीजिए ना, कर दो। Good morning, dear students. So today we will discuss the pile foundation. So what is meant by pile foundation? In the previous lecture we have discussed there are two types of foundation. One is shallow foundation. One is shallow foundation. And another one is deep foundation. So the shallow foundation and deep foundations are the types of foundation and which are divided according to their depth. So basically, when the depth of foundation is very high. So what is that criteria? When df by d is greater than 15. When df by d is greater than 15, then it will be called as a deep foundation. So again, the deep foundations are the foundations which are again divided into three categories. One is pile foundation, another is cast irons, and third one is the pier foundation. So these pile foundations are the foundation which are considered to be the slender structural member. So this is the very similar to the pile foundation where it is a thin structural member, it is a slender structural member when the depth of the foundation is more as compared to its cross sectional area, right? Then the another is coming picture, that is a pier. So we will consider this is the pier. The length is almost the same, but here the cross sectional area of this pier is very large as compared to the pile foundation. So these are the two types of foundation, and the third one that is called as the cast irons. Now what is meant by cast iron? You just see this is the here, this is the bottom, which is cross-sectional area is large as compared to pile and pier. You can see these are the three things. So here, these are the pile, then this is pier, and this is the pile well foundation. So third is the cast irons. So where you just see the cast iron is having the larger cross-section as compared to the pile and pier, right? So here, this is the hollow circular member. This well foundation is a hollow circular member. Hollow circular member means it is the cylindrical tube which is hollow inside, and there are three types of the cast irons. One is open cast iron, then there is another is a box cast iron, and third is the pneumatic cast iron. Right? So first is open cast iron. Open cast iron is the cast iron which is the hollow cylindrical tube which is having open bottom and top. So here you can see this is the well foundation. The well is being constructed over the field or over the yard itself, and then this is the well, hollow circular well which is used where there is a buoyancy force. This is the well which is open. So this is called as open cast iron, and India this is well known with the name well foundation. So this well foundation is further filled with the sand. So this is the member which is hollow. But just to increase the strength of this member, we will just fill that hollow member with the help of weaker material. Now, weaker material, good draining material, that is sand, is usually used for the well foundation. So these are the three, mainly the deep foundations are classified into three foundation. One is pile foundation. The piles are the slender structural member. Then this is the pier. This is the length is high, but the cross sectional area is more as compared to the pier. And the third one is the hollow cylindrical member where the cross sectional area is this much. As compared to that, this is the cross sectional area and the tube is a hollow, right? So these are the three types of foundation. Now tell me where these type of foundations are recommended. So these piles are the slender structural member which may be a circular, it may be a rectangular, it may be a square, or it may be a any shape. So that is used basically called as the pile foundation, right? Then the pile foundation can be a precast concrete pile, or it may be a steel pile, or it may be a cast in situ piles, right? So what are the basic functions? As we all know, where the piles are used, piles are basically used when the load coming over the structure is high, when the soil at a shallow depth is not able to sustain the loading which is coming from the upper side, right? Therefore, when the load coming over the structure is high, when the soil at a shallow depth is not enough to take the load. Then third, when the soil is subjected to any lateral stresses or when there is an uneven loading, then there is a lateral pressure. So in all these conditions, the pile foundations are being used. Right? So here, these are the various functions just to transmit the load of the solid ground, means just to transfer the load of the superstructure over the harder layer. Then to resist the vertical, lateral and uplift load, then the soil is immediately beneath its base, do not have adequate bearing capacity, and these are the various things. Now just remember, when we will go for the pile foundation, when the load coming over the structure is very high. In that case, if the hard strata is available at 6 meter depth or at 3 meter depth, in that case, the shallow foundation cannot be extended up to a large depth because of its economy. Therefore, in that case, we go for the pile foundation where the slender structural members are used to transmit the load through a soil. So here, actually, these are the soil. Then these soils are basically, these are the piles. These piles are always inserted in a group, and there is a group of minimum 3 piles. So once all the piles are installed, then it will be connected with the help of pile gang. It will be connected with the help of pile gang, and then further the load is kept over the pile foundation. So this is the basically the pile foundation. So these are the small slender thin members which are used to transfer the load of the superstructure over the harder layer. So this is the hard layer. So in such cases, these are economical as compared to the complete foundation which we will provide throughout the depth. Right? Then just to resist the lateral pressure or uplift pressure. Many times this may be subjected to uplift pressure due to buoyancy or anything else. Then sometimes it may be subjected to lateral stresses. In all these cases, we will go for the pile foundation. Then sometimes the load may be irregular. On some portion the load is high, on some another portion the load is less. In that case, there is a chances of unequal settlement. So in that case, we again go for the pile foundation, and then these are the various functions of the pile foundation. So the next part is the classification of the pile. The piles are classified in different manners. So first classification is based on the material used. So we all knows about the things in ancient days, around 80 to 100 years back, there was no invention of the concrete and people are using timber as a construction material. Because at that time, that timber was available in ample quantity and in cheap rates. So people are using timber as a construction material to transfer the load of the superstructure over the harder strata. Further, there is an invention of the steel. Timber is absolute and this steel is come in picture due to there are number of disadvantages of the timber material. So timber is subjected to decay, timber is having low bearing capacity, low strength, and therefore steel is come in picture. But again there is a drawback of the steel. Here it is subjected to rusting when it come in contact with the water and another material. So here another salts and dissolved ions, these is subjected to corrosion. So thereafter concrete coming in picture. So concrete is a very ideal construction material which is having high strength. It is not subjected to any decay and corrosion, and therefore nowadays concrete is becomes most commonly and economically used for the construction of piles. These piles may be a precast pile or it may be a cast in situ pile. What is meant by precast pile? Precast piles are the piles which are constructed over the bed and directly used over the transported over the site and installed with the help of a hammers. And cast in situ piles are the piles where the boreholes are made and the construction is made. And then fourth type of piles are the composite pile. So what is meant by composite pile? Composite piles are the piles which are constructed with two or more material. two or more material means it may be in the composition that it may be a concrete or timber, it may be a concrete or steel, it may be a steel or timber, whatever. It may be constructed with two or more material, then it will be called as composite pipe. But there is a main disadvantage of composite pipe is that over the intersection of these two material, the pipe is become a weaker material, and the bonding between the two material is again very difficult, and at the joint, the section may be weaker. Therefore, this is not being used over the field. And nowadays, most commonly used pipes are the concrete pipe. Then the another classification, which is the classification based on method of installation. So first, there is a driven pipe. What is meant by driven pipe? Driven pipes are the pipes which are precast pipe. Suppose this is very similar to the nails which we are inserting into the wall, right? So what we are doing, we are just obtaining the nail, just putting it over the surface of the wall, and just we are hammering it at the top. So while due to the hammering or due to the energy we are imparting over the top of the nail is getting inserted into the wall. The same thing we are doing over the field with the precast pipe. You just see this is the pipe with a very similar precast means it is already constructed over the field, transported over the side, and then just placed over the surface and hammered it with the hammering it into the soil. So this is called as driven pipe. I'll just show you the photograph of the driven pipe. So these are the driven pipe. You can see this is the precast pipe, just similar to this way, where it is being transported from the casting yard to the field. It is placed on its position, and then the energy is imparted with the help of hammer at its top. While penetrating this, the dolly or helmet is placed at the top of the pipe. Suppose this is the pipe. So here, in between this hammer and the pipe top, the cushion is placed. Here you can see this. My finger is just similar to the cushion, and here then the hammering is done. So while hammering, due to this cushion or due to the dolly or helmet which is placed at above the top of the pipe top is not getting damaged during the driving operation, right? So this is the process which is called as driven pipe, where the precast pipes are inserted into the soil with the help of a hammer. So this is the first position at which the concrete pipe is placed on its required position. Then just by giving the hammer blows, this pile is being inserted into the soil, and this is the final position at which pile reaches to the hard straight. So here this is called as driven pipe. Naturally, the driven pipes are the displaced pipe. Here you can see this is the loose soil and this is the dense soil. So in this case, when we are driving this pipe, it will just densify the surrounding soil. Due to the vibrations which are created, it will densify the surrounding soil. So these pipes are called as driven pipe, right? Then the another is driven and casting situ pipe, but before that we will go for the bored and casting situ pipe. These driven pipes are the precast pipe, whereas bored pipes are the casting situ pipe. Bored pipes are casting situ pipe means the first borehole is made with the help of the augers. You can see these are the large size augers which are used to make the hole into the soil. So have you seen a drilling machine which we are using for the drilling the nail into the soil, nail into the wall? I think you all must aware about the drilling machine. So what is drilling machine? In the drilling machine also there is one rod. This rod is machine operated rod, and around the rod there are the threads which are made. So just we put that drilling machine over the wall and just give the pressure. By giving the pressure, that is the motorized mechanism or the mechanical energy, electrical energy is used to operate this. Then it will just make the hole into the wall. Once it will make the hole into the wall, then we will insert the nail. Then the same thing we are doing over the field, which is called as bored pipe. So these bored pipes are the casting situ pipe, where with the help of these augers, boring is made up to a required depth, up to the required diameter, and up to the required depth, the borehole is made. Then once the borehole is made, you can see this is the procedure. Here we'll just make the borehole of a required dimension. This is the diameter and this is the depth of the borehole. Once the borehole is made with the help of auger, then this gray color line shows the casing. What is meant by casing? Casing is the hollow circular pipe of a metal, and nowadays PVC is also being used. So that casing is a hollow metal tube or hollow plastic tube of a same dimension. Once we make the borehole, there is a chances of the falling or caving of the sides of the borehole, which will just occupy the space into the hole. Therefore, this gray color casing open hollow circular pipe is inserted up to a required depth, and then once it is being inserted, this casing is inserted, it will just stabilize the surrounding wall. It will just stabilize the surrounding wall, make the wall stable. After that, if the pipe is a reinforced pipe, then the reinforcement cage which is prepared over the side and just lowered it at the bottom of the hole. Once it is being lowered at the bottom of the hole, then the concrete is poured from its top. Right? So then it will be called as cast in situ pipe. Only cast in situ pipe, or it is also called as bored pipes. Right? Then this is the procedure which is used for the bored pipe. Now, if suppose many times we just want to enlarge the bottom of the pipe, then the hammering is done at its top. And while making hammering, we are just lifting the casing. Here you can see this is the procedure in which the hammering is done over the top of the pipe, and due to the hammering, naturally the concrete is just make a bulb and form a bulb at its bottom, and this the area of cross section at the bottom of the pipe is enlarged just by driving the hammer at its top. But while driving, simultaneously the casing is lifted up, so that this can be possible into the wall. So this is called as driven and cast in situ pipe. Here this is the bored and cast in situ pipe, where the diameter is the same throughout. Many times, just to enlarge the base of the pipe, the driven cast in situ pipes are being used. Right? Then the next classification is the screwed pipe. What is meant by screwed pipe? It is just similar to the in the previous driven pipe. If there is a nail is having a plain surface, and therefore it will be just inserted by just giving a blows at its top. So what is the difference between the nail and the screw? Nails are inserted by giving a hammer or by giving a dynamic pressure at its top, whereas screws are just screwed into the wall just by giving a moment or just by giving a clockwise thrust. It will be inserted into the wall. The same thing we are doing into the screwed pipe. And the last one is the jagged pipe. What is the difference between the jagged pipe and driven pipes? Both these driven pipes and jagged pipes are same, where the dynamic energy is used over here and the static energy is used over here. So dynamic energy means what? The pile, suppose this is the pile, this is the pile, there the pile is inserted by giving a hammer blows, so it will be a dynamic energy, and that is called as driven pipe. When these piles are just pushed into the soil, just with the help of hydraulic jack, the energy is a static sustained energy which is used to just insert the pile into the soil, then it will be called as jagged piles. And in combination of all these things, the water jets are also used and vibratory action is also created just to make easy to insert the pile into the soil. So these are the classification based on method of installation, right? Then the classification based on use. So this is again the most important one, classification based on its use. So here the load bearing pipes, as we all know, piles are used to transfer the load of the superstructure over the hard structure. So then the function is same, it will be called as load bearing pipe, where the pipes are just used to transfer the load of the superstructure over the hard structure. Then the second type of pipe is called as compaction pipe. Here you can see this is figure 1, where the piles are used just to transfer the load of the superstructure to the hard strata. Means here you can see the opposite reaction coming from the periphery as well as from the tip of the pipe, right? Then the another is the compaction pipe. So here you can see this is the compaction pipe. Compaction pipes are the pipes which are not a load bearing pipe. Means pile will not carry any structural load. It is the pile which are made up of a weaker material like sand, and these piles are used to just increase the bearing capacity of the soil. Means this pile is the part of a ground improvement technique. This will not carry any structural load. So here you can see this is the loose soil. This is the loose sand. This loose sand is very difficult to densify at a great depth. Therefore, the boreholes are first made into the loose soil. You can see here the boreholes are made into the sand. Then the sand is poured. The extra sand is poured from the top, and then the vibrations are created. Due to the vibration and the extra material which is pouring from the top, it will radially densify the material. You can see this will just radially densify the material. This pouring of sand will radially densify the material. You can see this is the sand pipe which is filled with this, and then it will be just densify the material. The same action will be created from this side also, and therefore now the whole area here you can see these are the different piles which are used over here, and this will radially densify the soil. It will radially densify the soil, and now this whole portion of the soil can take more load. But these structural member or these piles are not a load bearing pile. These piles are not a load bearing pile, which are just used to densify the sandy material, which is very difficult to densify. And then the whole area can take more load. So this is called as the compaction pipe. Then the third pipe is a tension pipe. So what is meant by tension pipe? The pipes which are always in a tension. Means you can see here this is the water table, and over the water table if there is a structure, this is the lightweight structure. This is lightweight structure. This lightweight structure, if suppose we will provide the anchor here piles. So these piles are, there are one load is from the superstructure, and there is another load that is due to the buoyancy force, or that is the uphill pressure due to water. So in that case, these piles are always in tension. Then there is another case of a transmission line tower. So here you can see this is the transmission line towers, and this is the tower which is situated in the valley. So here these are the piles which are inserted just to anchor down the structure, but there is one more force which is just trying to lift up this transmission tower up, and therefore these piles are always in tension. So this is the case of a tension pipe, right? Then the next classification is a sheet pipe. What is meant by sheet piles? Sheet piles are a special type of piles which are placed side by side, which are placed in a series and form a retaining wall, right? So it is called as a sheet piles. Basically, these sheet piles are used for the temporary sheeting and for the temporary supports in excavation as well as for the waterfront structures. So here you can see these are the piles which are called as sheet piles. These are generally made up of a metal or concrete. These piles are placed side by side, and then it will be form a continuous wall. It is called as sheet pile. Basic function of sheet pile is to just retain the material on its one side or both the sides, right? Then third is the fender pile. Fender piles are the sheet piles which are used to protect waterfront structures from the impact of ships and vessels. So you can see this is the harbor structure. You can see the structure is a harbor structure, and these are the fender piles. You can see these are the fender piles. So these fender piles are basically protect the main structure from the impact of load. So here there is a sheet pile, and after the structure, these piles are provided some distance away from the harbor or main structure, so that whatever impact of the sheet or any waves, that may be just break by these fender piles, right? So this is called as the fender pile. And last one is the, which are used to provide the anchorage or anchor the sheet piles. Many times these anchor piles are used to give the additional anchorage to the structure, right? Then the next classification is, this is the most important classification, where this is the classification based on mode of transfer of load, right? So this classification is an important classification as per the structural point of view, right? So here, end bearing pile, friction pile and combined pile. So first we will discuss the end bearing pile. What is meant by end bearing pile? As we have already discussed, we are always trying to transfer the load of the superstructure over the harder strata through this pile. Now suppose this is the hard strata, this is the hard strata, and this is the pile which we are trying to rest over the hard strata, so that it will provide a same or more reaction from the bottom, and then it will be in a stable condition, right? So this is where this is called as end bearing pile, where the piles are just extended up to a hard layer, and the hard layer will take a load. Then it will be called as end bearing pile, where the reaction is coming at the bottom, at the tip of the pile, and it will be acting from the bottom, right? Then it will be called as QP. So here you can see these are the end bearing piles. End bearing piles transfer the load through their bottom tips. The ultimate bearing capacity depends upon the bearing capacity of rock. Naturally, these bearing, why we are reaching it, or why we are extending this pile up to the hard strata? So here we are just resting it over the hard strata, so that it will have a more capacity as compared to this load. Then only it will be in a stable condition. It will provide an equal and opposite reaction from the bottom, and therefore the pile is in a stable condition, right? So this is the timber pile. You can see this is the in situ reinforced concrete pile. In situ means what? It is the pile which is constructed over the field. Then it will be called as in situ RCC pile. Here also the reaction is coming from the bottom, and it will be coming over the cross-sectional area of the pile, which is considered as a tip of the pile. Here we are resting it over the hard strata, and therefore the reaction is coming over the tip of the pile. Therefore it will be called as tip resistance, right? So this is the end bearing resistance. Now in the second case, the pile, this is the second pile, which is called as a friction pile. Why it is called as friction pile? Because here many times if the hard strata is at a large depth, suppose hard strata is available over here, suppose the hard strata is at 20 meter depth. So many times it may not be feasible or economical to extend the footing up to a 20 meter depth, and therefore in that case it will just leave up to a certain depth, and it will never reaches to the hard strata. So here it is a suspended pile, it never reaches to the hard strata, but it is being surrounded with the soil. So here this is the surrounded soil and the pile. In such cases, the frictional resistance, I just push this into the soil. So here the frictional resistance is developed due to the surrounding soil and over the periphery of the pile, and that is called as the frictional resistance. Here you can see this is the frictional resistance which is coming in the opposite direction, and here this is just resist the QU, or the load, whichever load coming from the opposite direction will be taken by this QS, right? In this case it will never reaches to the hard strata, and whatever load is taken by the frictional resistance developed over the periphery of the pile due to the surrounding soil, right? So this is the another case. Here you can see the frictional resistance is developed over the periphery, where if it will never reaches to the hard strata, right? The friction pile do not reach the hard strata. These piles are transfer the load through the friction between the embedded surface of the pile and the surrounding soil. Then the next classification is the Combined end bearing and friction pile means here the piles are resting over the hard strata and it is surrounded by the soil. So in such cases, the load is taken by the tip resistance as well as the frictional resistance both. Then it will be called as combined end bearing and friction pile. So here you can see this is the skin friction and at the same time it reaches to the hard strata, so it will take a tip resistance also, right? Then the next classification is classification based on load, classification based on the displacement of the soil. You can see this is the last classification which is called as displacement of the pipe. So what is meant by displacement? Suppose and just you can just remember the example again, nail. I just wanted to insert the nail, a small and a thin nail which I just wanted to insert into the wall. So while inserting, this much amount of mass is entering into the compacted surface of the wall. So naturally it will disturb the surrounding wall surface. So when we are just inserting the pipe, inserting the nail into the wall, it will just disturb the surrounding material of the wall, and therefore this will be called as a displacement material, which cause a displacement of surrounding soil. Which cause a displacement of the surrounding soil. Therefore, the same thing when we install the pipe into the soil. If the soil is in a loose condition, so due to the insertion of this pipe, the material is getting densified. The surrounding material is getting densified. If the soil is in an already compacted condition, then it will just lift up the surrounding material. Means the soil is disturbed. The soil is disturbed due to driving of this pipe. So these piles, generally the driven piles or the precast piles are called as displaced pile, which just disturb the surrounding material. And non-displacement piles are the piles which are bored pile. What is exactly doing in the bored pile? In the bored pile, we are just excavating the material. You can see these are the bored piles. These are the driven piles. When we install such piles into the soil, it will just disturb the surrounding soil. It will just disturb the surrounding soil. Opposite of this, when we make a bored pile, we are just removing one material and pouring another material. We are just removing, make the hole, remove the material, pour the another material like concrete. In that case, the surrounding soil is not at all getting disturbed, then it will be called as non-displacement pipe. Is it clear to all? So these are the various classifications. Then next is the what are the different methods of load carrying capacity of pipe? There are 4 methods which are used to determine the load carrying capacity of the pipe. Out of these 2 are the analytical approach and these 2 are the field approach. So analytical approach, here we are just taking into consideration the various properties of the soil, and here the efforts which are required to penetrate. What are the efforts? Means we are just hammering it at the top, so it will just provide a resistance. So how much resistance or how much efforts we are required to just insert the pipe into the soil, according to that the load carrying capacity of a group is calculated. Naturally, if the soil is in a soft condition, the number of blows required to penetrate the pipe is less. If the soil is in a very steep and hard condition, it will take more efforts. So from that data, we can just identify the load carrying capacity, that is called as dynamic formula. Static formula is based on the theories such as Kawasaki and Marov bearing capacity, and these 2 are the penetration test and the pile load test, which are conducted over the field to determine the load carrying capacity of the pipe. So these are the various approaches which are used to determine the load carrying capacity of the pipe, right? Then this is the static method. This we will discuss in detail. So pile driving method. What are the pile driving method? Pile driving methods are the methods which are used for the driven pile or for the precast pile. This is the precast pile which is driven pile because we are driving it into the soil, just applying the energy at its top. So here, this energy can be imparted by the different hammers, and that hammers are called as drop hammer. Then there is a steam hammer. Then there is a diesel hammer, pneumatic hammer, and different types of hammer. So here you can see these are the hammers which are a rotary mechanism. It is the truck mounted rotary mechanism which is used to install. Now you just think we are requiring so much effort for inserting the nail into the soil. So naturally this much amount as compared to nail, this is the larger section and which require more efforts to insert, and therefore this rotary mechanism is used. So this rotary mechanism consisting of a hammer. Here you can see this is the hammer. Then there is this orange color showing the helmet or dolly. This is helmet or dolly, and below this helmet and dolly there is a cushion. This cushion is actually the protective layer in between the hammer and the pile top. So that is called as cushion. So here you can see this is the helmet. You can see this is the helmet, and this is the pile section. Here you can see this is the mechanism which is used, generally a rotary mechanism which is used to just insert the pile into the soil. So this is the helmet, and into the helmet and pile there is a cushion is placed. That cushion is in the form of core, and nowadays the plywood sheets are being used to act as a cushion. So what is the function of cushion? Cushion is actually protecting the top of the pile from the hammer, right? Then there are different types of hammers which are used. This first is a single acting hammer, and the another is the double acting hammer, right? So what is meant by single acting hammer? In single acting hammer, the first operation is by gravity. Means just lifting the hammer manually and dropping it by gravity. Lifting the hammer manually and dropping it by gravity. Lifting the hammer by manual means and dropping by gravity. Then it will be called as single acting hammer. So many times for lifting it, the various efforts are required, and that is given with the help of a steel hammer where the steel is used as a fuel. Then there is a diesel hammer where diesel is used as a fuel. Then there is a pneumatic or the compressed air where it will be used as a fuel just for lifting. So here this is lifting and dropping. Lifting is mechanically and dropping by gravity. Then it will be called as single acting hammer. Whereas double acting hammer, both the operations are mechanical. Means lifting, dropping. Both the operations are mechanical operations, and therefore the efficiency of double acting hammer is more as compared to the single acting hammer. There are short and quick blows. Therefore, this is more efficient method. And nowadays, this diesel hammer is most commonly used over the field because of its portable nature. You can see this is a small hammer, this is a portable hammer which can be used anywhere, and fuel is in the form of diesel, so it can be used economically everywhere. This is the vibratory pile driver. So here, these are the vibratory, and this is the vibratory pile driver. With the help of this, the static energy is provided over here just for the insertion of the pile. Due to this method, the pile top is not getting damaged, right? Then this is the jetting technique. This jetting technique is supplementarily used for all the methods of driving of pile, where the strong water jets are provided at the bottom of the hole so that the soil is getting pulverized, loosened, and the penetration will be easy. So this is the augering method. This is for the bored piles, where piles are driven into the soil. By making a bore hole, you can see this is the hammer. This hammer is height of the hammer is around 5 to 6 meter. Then this hammer is inserted into the soil. Just the soil is removed and the concrete is poured. You can see this is the concrete mixer. Once the hole is made, then the concrete is poured. Then this is called as a bored pile, and it is a cast in situ pile. So this is another method, the same method in which the soil is being removed by making the bore hole. Then this is the tension pile. This is the driving method. And this is the pile load test, where the pile load test is being conducted over the test pile or over the actual pile. It is very similar to the plate load test. So I think this is the theory regarding the pile. In the next class, we will discuss how the load carrying capacity of pile is calculated. So we have now discussed various things about the pile foundation. So here you can see this is the pile, then these are the pier, and the cross-sectional area is more where the hollow sections are provided. In that case, it will be called as a well foundation. I think this part is clear to you, right? So in the next class, we will just discuss how the load carrying capacity of a pile is calculated, right?